Hi everyone, today I'm going to talk about the influence of the inflows and water demands of the South Saskatchewan River Basin in Saskatchewan on the river's outflow to Manitoba. Here you can see the South Saskatchewan River Basin as a part of the Saskatchewan River Basin. Interprovincial flows of the Saskatchewan River Basin are governed by the Prairies Province's Water Board Master Agreement on Apportionment. According to this agreement, Alberta has to pass 50% of the Saskatchewan River's annual flow to Saskatchewan Province, and the Province of Saskatchewan has to pass 50% of this flow plus 50% of the local flow generated within the province to Manitoba. Due to the crucial role of the interprovincial flows in the Saskatchewan River Basin as a multi-jurisdictional river basin, I try to understand the role of the South Saskatchewan River Basin's water system components on this river's outflow to Manitoba. For this purpose, I conducted a global sensitivity analysis on the water resources system model of the Saskatchewan River Basin developed in MODSIM-DSS using VARS-TOOL. VARS-TOOL is selected for this study because of its comprehensive multi-approach, multi-algorithm toolbox, which is well designed to match dynamic earth and environmental system models. Here you can see a screenshot of the South Saskatchewan River Basin water system model in MODSIM-DSS. As you can see, two main river flows from the South and North Saskatchewan rivers are entering this river system, and a number of local inflows generated within the province are joining this river as well. The irrigation and non-irrigation demand sites are shown with purple squares in this model, and the model response is outflow to Manitoba. In this study, I wanted to examine the influence of the main components of the water system on the river's outflow to Manitoba. The parameters representing these components are shown in this table, including irrigation and non-irrigation demands, local flows, main river flows, and also the lower and upper bounds of these parameters are shown here as well. The model response in this study is selected the RMSE of the simulated and observed river outflows to Manitoba. VARS parameters for this study are customized for the South Saskatchewan River model. As you can see here, 20 parameters are selected as VARS factors, and progressive Latin hypercube sampling as the sampling strategy. The number of stars was set to 20. In order to study the relationship between the computational budget and the confidence intervals, two resolution parameters were selected. Under experiment 1, it was selected 0.1, resulted in 3,620 function evaluations, and under experiment 2, it was selected 0.2, resulted in 1,620 function evaluations. Here you can see some results of this study. Based on the directional variograms, the South Saskatchewan River inflows and the North Saskatchewan River inflow are the most influential parameters, followed by the local inflow from Tobin Lake. Based on the variograms, you can see that variograms of these three most influential parameters are considerably higher than other parameters. Therefore, I plotted directional variograms for other parameters separately to clearly show the ranking of these parameters. The other result of this study was the relationship between confidence intervals and the computational budget, and you can see here, although the strongly influential parameters show smaller differences between the two computational budgets, confidence intervals of the other parameters become narrower, up to 26% here. Thanks for your attention, and in case of any questions regarding this study, please contact me at this email address. Also, you can visit VARS-TOOL website for more information on methodology and applications of this toolbox. Thank you.